Hi, everyone. My name is Joris Peels, and this is another edition of 3D Printing News Unpeeled, brought to you thanks to 3dprint.com. So, what are we talking about today? Well, first, this is a really, really nice application. I really, really hope we're seeing more of this. Now, we're seeing a lot of things with 3D printed turbine blades, mainly Siemens and Oak Ridge Department of Energy related things. Now, part of this is that um, these things are really expensive to manufacture. So any kind of tooling increase or 3D printing the blade itself would be very advantageous. The other thing is that these things are kind of limited. Well, the bigger you make them, sometimes the more efficient they are to a certain extent. So and the problem with that is that, well, you can't really make them in a central location in, I don't know, Ohio, and then ship them all across the country. At one point, the size limits are going to be so big that no matter how big your truck is or something, it's just not going to fit. It's just not going to be able to corner essentially anywhere, and you're not going to be able to transport this stuff around the world. So people are looking at 3D printing the towers, right, in concrete, right? G was doing that, and then some other people, or print the actual the blades and all the other stuff in situ at the location where you actually want to put the tower. That will save on the transport cost. And the other thing is just to generally just optimize any kind of components, any kind of like power storage, energy storage, construction, optimization of the structures with additive to get a better result of these important systems. Now, this is driven partially, I think, by Siemens most of all, by the GE wind turbine unit, which I don't remember what the name of at the moment, and also I think at the same time by very much Oak Ridge Department of Energy. For Oak Ridge and Department of Energy, this is a fantastic thing. Of course, it's additive manufacturing, which they like, and they've done a lot of research into, and it's energy and energy related stuff, and they're really into green energy and sustainable systems. So this is a really good thing. Now, another thing we've looked at, and that has been happening a lot, is the 3D printing of tooling. So the tooling for these things is huge. We've always seen these turbine blades, but we probably have no idea how large they are. And the tooling for these parts is, of course, really, really ridiculously expensive. So what TPI Composites is doing with the University of Maine Advanced Structures and Composites Center and Oak Ridge is to look at this wind turbine tooling, yet again using additive manufacturing. Some of the segments are 18 meters long. And they're using a very, very big printer, Ingersoll master print system to print this tooling. Now, that's great. And it's a daunting challenge to try to make something as accurate as that, as large as that. And also, of course, because it's a tooling element, it needs to be machined post-process as well. So the entire production time, the printing plus the post-processing, is really, really, very, very long. Now, what they've done is something really exciting. And which is one of those ideas that you're like, oh, wow, this is like super, super obvious and also really, really elegantly smart again. So they put heating elements into this mold tooling. They've co-extruded wire, and then this gets a uniform mold temperature. And that uniform mold temperature, of course, can make sure that the mold can extract a tool quickly and safely, and that doesn't stick at one part, that it processes and cleans out nice. And so they're actually improving using 3D printing with this co-extruded resistive wire. They're improving the quality and the usability of this mold. I thought that was a fantastic idea. We've always talked about kind of mold solutions and superior molds and superior tooling from powder fusion, other types of technologies, and conformal cooling, all this kind of stuff. But heating elements, that's something that, I don't know, I feel kind of stupid to not have thought about that. And I think this is a really wonderful idea, especially for these tools. 18 meters long. This is really ridiculously long. So any kind of improvement there in cycle time or just getting that tool out quickly and reliably is going to really, really impact the cost. So this is a really wonderful thing, I think, actually. The next thing is, sorry for the low quality picture, is a kind of a review article, I think, on something that also I had not ever thought of. We've seen 3D printed pills, right? We're looking at 3D printing the pill, the surface of it, the internal structure, to change the release kinetics, right? So that you could take aspirin, you can print it in a certain gaplets, little holes in it, so it dissolves much quicker. You have faster working aspirin. Now, of course, you could do tons of other different things. You could put poly pills, you could put a pill in a pill in a pill, so one will dissolve first, and then a certain order that could then cure you in a better way. So these, for medicine, it's already happened a lot. Now, there's other people 3D printing nourished, for example, 3D printing kind of gel kind of gummy bear kind of nutrition solutions as well, which could be customized or mass customized according to certain qualities as well. And there's people looking at mass customized nutrition and with 3D printing as well. But what I hadn't thought of, again, and this is really, really wonderful, is the idea of you 3D printing probiotics. So these guys are looking at keeping the probiotics alive, which is, of course, very, very important, using bioinks to print them, and then to develop new probiotic type of foods. Like think a candy bar with a probiotic on top of it, or a probiotic on an ice cream. I don't know. So different types of formulas, different types of delivering probiotics to people, and also different release systems, like different on-demand delivery systems, different ways of like maybe taking a probiotic that releases itself throughout the day or throughout the week or whatever, that kind of thing. So I thought those were kind of interesting. And it's a Science Direct. It's on Science Direct, the paper. It's linked in the post. And yeah, I'd never really thought of printing probiotics, even though we think of printing live cells and lots of other applications. We think of printing medicine and nutrition things a lot as well, and 3D printing food for hospitals and 3D printing food, like steaks and stuff. Probiotics are something new. So I thought that was quite interesting myself. The next thing is a blurred 3D printing. So this is micro-optics fabrication using blurred tomography. So what they've done is they've used a volumetric 3D printing method, volumetric additive manufacturing, VAM, which is kind of like a term being used by some of the people involved in these volumetric additive manufacturing processes, which again illuminate a entire part or entire cross section or most of a part in one go, rather than illuminating just a layer or just illuminating a little portion of it or illuminating one whole slice or something. And this tomographic process is being hyped up. Like Volumetric got bought. A lot of other companies come up with lots of interesting ideas. And it's easy to understand, right? Volumetric and manufacturing. Oh wow, we illuminate the whole object really quickly. Boom, it's much faster, right? But there may be some really exciting ways that volumetric manufacturing could maybe even go further than this. And this is an example of this. So what they've done is they've blurred the projection in order to eliminate artifacts in the print, in order to get like a smoother printed surface. Now, one of the biggest problems we've always had is printing optics, because you can't get smoothness because there's layers somewhere, right? Or there's some kind of artifact, or you really can't get the optical quality. Some people have been trying to do this. Glassamer, other types of companies have tried to do this with either printing glass filament or printing glass in different types of ways. Lux Excel, which was bought by Meta, also did it, but they did it with printing droplets that kind of like transitioned into each other, kind of, to make that clear surface. And that also was able to do optical things. But nobody's really crack this into an industrialized process. And of course, for optics, micro optics, optoelectronics and stuff, this is a huge potential market. It's a nascent market a lot. Like now, a lot of people are doing in the lab, but a lot of people expect generally for electronics, for optoelectronics, for photonics and stuff like this, for this work to really kind of end up, having kind of MEMS-like devices, which are quite small, very, very functional, and can do lots and lots of things that we need to make really, really precise little mirrors and glass structures, diffusers, Fresnel lenses, stuff like this. So there is a real market here, and a real market that needs to be addressed. But of course, this is an electronics market. They're used to making millions and billions or something, and our volumes are not like that usually. So it's very difficult for us to kind of see those markets. But if we could do it, this could be huge. Now, these guys say they can do it. So what they've done is they've made this lens. They've compared it to a commercially available similar plano convex optical lens, right? And they say that it equals the performance of that lens, which means that eventually, if they can scale this process, if they can show reliability, repeatability, they may actually be able to ship these things in a commercially viable way. Now, of course, we may be many years from that. But the interesting point here is that the tomography or volumetric additive manufacturing, these collection of technologies, could be used in a way that we may have not seen before. Maybe they lead to new parts that we cannot conceive right now, because we're in this layer by layer type mentality. So that's for my first takeaway anyway. The second takeaway is, well, can't we like blur, let's say, a lot of other types of scanning heads or galvos or lights and stuff to get a better optical result? That could also be something that we should maybe look at. So this is by Daniel Weber, Yu Yi Zhang, Kathleen Sampson, and a bunch of other people. It's published in Optica, and again, it's linked. So yeah, have a look at that. I think it's a really interesting paper, and it's also something I hadn't thought of. Again, a lot of stuff I hadn't thought of actually. Kind of a humbling day, all in all, which is very good. Means it's exciting things are about to happen, and yeah, maybe this volumetric stuff has legs, but in a way that we have never conceived it. Anyway, this is 3D Printing News Unpeeled. Thanks to 3dprint.com. You guys have